Hi, we are working on Mystery 3 today. So you guys should have watched the mystery talking about acids and bases. This is kind of the foundation of chemistry that you were working on with this lesson, and I have it set up a little bit just to show um, what we would have been working on had we been in the classroom. I know you watched the video on it, but sometimes it's a little different to see it yourself. So again, if you want to try any of this at home, that is fine. Make sure you ask a parent first for them to help you. I don't have all of the materials in my own house to do this, so I'm kind of improvising with some of the stuff that I do have. So the basic gist of the lesson is focused on being able to test what things are acids, which things are bases. So we use what's called a pH scale. I wrote it down here so that you can have a visual. So when you look at water is considered neutral. It's not either too acidic or too basic. So that's the measurement that we use from 0 to 14. So 0 being acid. So think of something like a lime or a lemon, the juice of that, very acidic, all the way to the most basic, which would be a 14. So in real life, you may use this, and some of you may even have this at home if you have a pool in your yard and you need to test the chlorine levels, which is something you do if you have a pool in your yard. And
we don't have a pool in our yard.
No, we don't have a pool in our yard. So you have to test, and you can get little kits at the pool store. And that's all that it's doing, is testing to see what the water is, if there's too much acid or too much base in the water, because you don't want either, which would be not good. Did you take my straw? Oh, here it is. All right, so bless you. So we're going to be testing the reactions between different items, and we're using baking powder and baking soda. So you may have these things in your kitchen. Your parents may have them. They are two different things, and they're going to cause two types of reactions, which hopefully you can see. I'm going to set this up on plastic, so I have this plastic sheet.
That's
slide.
my schoolwork.
Yes, that's your schoolwork. So just to keep it contained and so it doesn't make a huge mess. And I know that in the experiment
Mama,
you used...
Look up. These are his swords.
Lovely. We used cabbage as an indicator. So an indicator is what turns color, whether it's too acidic or too basic. So I don't have cabbage in my house. It's not something that we really eat. But I do have beets. And beets is another indicator that you can use, a natural indicator. So I have some beet juice here. So beet juice is typically red, and if it becomes too high on the pH scale, so that means more of a base, it's going to turn more purple. So I'm going to look for that color change as well. Give it a shot. I don't know if it's really going to work or not, but we will see. So the thing that changes the color, the pigment that changes the color, is called an anthocyan, and it's just a chemical, naturally occurring chemical reaction. So scientists have created different things, like with a testing kit, using different chemicals to do the same thing that foods and things that occur in nature. So there's lots of different plants and vegetables that do this naturally, which is pretty cool. So you don't even really need to have the chemicals, but they're there as we advance science. But you can totally use this with just all natural ingredients. So we're going to start with the very basic neutral water. So I'm just using a straw. This is the part you would do in class if we were there, to gather some water. And I'm just doing
Are you okay back there, Drew?
drop. So I'm doing 2
No, I'm not.
drops, and we're going to test the reaction with both baking soda
I'm not happy back.
and baking powder. So we're going to start with baking powder first. And I'm going to make sure that we can see this better. So that one's empty. I was going to add something else to that, but let's see. All right, so we have our water that's out of the way. So let me see. It's hard for me to get an idea here, if you can see that or not. Slide it up closer. All right, so you can see looks like almost like little jello spots here. So we're gonna start with baking.
And that's me.
All right, don't touch the water. You can't touch this once I put the chemicals on, right?
Why?
Because. So this is the baking powder. And what do you see happening? What's happening to it?
It's mixing.
It's mixing. It's kind of fizzing a little bit, right? Okay. And then it's just kind of chilling there.
Yeah.
So we got a little bit of a reaction with the water and the baking powder.
And the baking powder.
This is the baking soda. And what kind of reaction do you see there?
That's bad.
It's bad. It's not bad.
That's pretty bad.
So with the baking soda, we didn't really see any type of a reaction. It just
smacked it on.
It didn't smack it on. It is just kind of mixing in with the water, not really doing much beyond that. Okay, so those are the two different. So baking powder here, and then the baking soda here. So that was with water, which is again a neutral item on our pH scale. So you would expect to see less of a reaction using water than any other material here. All right, so our next item we're going to test is vinegar, and I have what's called red wine vinegar. So there's lots of different kinds of vinegar. The level of acidity in the vinegar varies depending on what kind you have, but it should be pretty accurate with what we see. So we have our vinegar down. We're going to start with our baking powder. And
ooh, that's turning different.
So we see more of a foaming up. You can even hear it a little bit. It's pretty cool. So lots of fizzing. And the vinegar, so it started out that kind of like pink color, and as you can see, totally changed color as well, which is pretty cool. So we'll let the rest of the fizzing happen, and it turned the vinegar almost back to a white color. Now we're going to do the baking soda, and we're going to compare the reactions. So baking soda, whoa, look at that fizz. So that was definitely much more of a reaction with the acid in the vinegar. So way more of that fizz coming out, so actually creating the air, the carbon dioxide. And there are chemistry labels for the reactions that are happening, which you will learn in high school. So
I'm going to.
It definitely, you will one day, yes. So as you can see here, this one came out much flatter too, so it kind of took a lot of that liquid substance and turned it into the gas, which was the fizz.
Ah.
So it got rid of some of that liquid because it had more of a reaction than our
Mama.
baking powder did,
Mama,
which is why
what
more of the
reaction?
liquid is still there. A reaction is when two things combine, and we are looking at either a solid, a liquid, or a gas. So a solid is something hard, right, that you can pick up and touch. A liquid would be more like water,
Yes.
okay? And then a gas is a substance that you cannot see, but you can
Thank you for wiping down my school.
you can breathe, like the air. The air would be a form of a gas. All right, so our last item to test is our beautiful beet juice. You gotta be really careful with beet juice because it stains everything, including your hands, your clothes, whatever it touches. Anthony, do you like to eat beets? No. Anthony used to love beets when he was a baby, and now he won't eat them at all. And his sisters will eat them, and I'm sure one day they won't want to eat them either. So we're going to start with our baking powder. And it's turning a nice pretty color. We're having some foaming up there.
Oh, I like
Is that
pink.
cool?
Yeah.
So it seems like the baking powder reacted very similarly with the water, more of a reaction with the vinegar, and this is more similar to the way it reacted with the water, which is probably going to indicate that the beet juice is less of a acidic nature and closer to the water on the pH scale.
On a pH.
And then we're going to look at the baking soda and the beet juice. And it's almost no reaction there, which again tells us that
it's gross.
The beet juice is more on the base side of the pH scale, probably closer to water. And I don't see a change in the color the way it was supposed to. Sit back.
I like the pink.
Yeah, is it pretty? So I know in the original experiment you were mixing the cabbage juice with water. I didn't mix this with water. I just had straight beet juice, so that probably had something to do with the color change too. Maybe it was just too much beet juice. I don't know. So I'm going to clean that up. And that shows us how we can test if foods are too acidic or too much base.
Can you help me get that little red piece off?
Sure. Can you hand me a napkin?
Napkin?
And just kind of getting to see that I only need one, thanks. Just leave this there. To see how the foods that we eat are different types of chemistry as well. So a lot of times you think of chemistry and you think of doing experiments like this with chemicals, but all of those things originally came from the foods that we eat, the plants that are in our environment, and that's how scientists originally came up with all of these ideas, was based on this type of stuff. So back to the question of the lesson, what would happen if you eat acid, right? You do every day. So you eat acid when you have different types of salad dressing. Vinegar is found in a lot of different things that you eat. A lot of your citrus fruit all have acid, high acid in it. So you like oranges, right? Those are very acidic. Oranges, lemons, limes, grapefruit, all of that stuff has a high acid component to it.
I hate lemon. It's so sour.
Yeah, well, that's the acid in the lemon that makes it taste sour too. And so what happens when you eat this stuff? Not much. Some people have more of a reaction to it in their body, and that's the chemistry of your body. So things like acid reflux, which you may have heard or you may have even had yourself, is when your body doesn't properly handle eating foods that have a lot of acid in them. And so you might have to take medicine for it, or you may have to avoid eating certain foods like that. But it's your body's own way of doing a chemical experiment in your stomach, which is kind of crazy. So once you finish watching the mystery and you're finished with this video, you're going to work on your Google form for the mystery and submit that in for today. All right?
Bye-bye.